There is a mountain in southern China where no truck has ever delivered a single brick. No road runs to the top. No crane has ever been set up there. For most of the world, that mountain would simply win. The project would get delayed for months, or the land would get torn open just to let machines through. China sent drones instead. In just 3 days, a fleet of 16 heavy-lift drones moved 180 tons of steel, concrete, and rigging equipment straight up the cliffs of Yunnan province. Not one tree was cut. Not one road was built. The materials just appeared at the build site, delivered from the air like the mountain was never a problem at all. That is not a special effects shot. That is a real power grid project that happened in May 2025. And it is just one piece of a much bigger shift that is quietly changing the way the world builds things. So how exactly does a drone replace a road? And why is the rest of the world struggling to catch up? Let us start from the beginning. Most people think the hardest part of building something is the structure itself. The steel beams, the concrete pours, the wiring, the assembly. But engineers will tell you something different. The hardest part is almost always just getting to the place where the structure needs to go. Think about building a power transmission tower on a mountain ridge. Before a single bolt gets tightened, someone has to figure out how to get hundreds of tons of material up there. That usually means one of a few painful options. Option 1 is cutting a road through the terrain. That takes weeks, costs a fortune, and in protected areas like forests or wildlife corridors, it might not even be legally allowed. Option 2 is building a cableway, a temporary aerial rope system to haul material up the slope. That also takes weeks to set up, and it only works for certain kinds of loads. Option 3 is helicopters, which are expensive per flight, limited in what they can carry, and hard to position with real precision. Every single one of those options has the same problem baked in. You are spending enormous time, money, and resources just to reach the starting line. The actual construction work has not even begun yet. For most of construction history, that was simply accepted as a fact of life. Difficult terrain meant difficult access. Difficult access meant higher cost and longer timelines. Nobody had a better answer until drones started getting strong enough to carry real weight. Now here is where the viral version of this story gets a little ahead of itself. You may have seen clips online suggesting that China has drones picking up entire tower cranes and dropping them onto buildings like toys. That image is dramatic. It is also not what is actually happening. A fully assembled tower crane weighs tens of thousands of kilograms once you count the counterweights, the mast, the base, and all the hardware. No drone flying today is lifting that whole machine into the sky. Not even close. What China is actually doing is more interesting, and honestly more useful. Instead of lifting a whole crane, these drones are doing the work that the crane used to do, but doing it in pieces, flight after flight, without the crane ever needing to show up at all. They are flying materials directly to the build point, with enough precision to hand things off to workers on a ledge, on a tower, or on the side of a mountain. The machines making this possible are not toys. One of the key platforms is a drone with 12 propellers spread across 6 axes, designed specifically for power grid construction, capable of carrying loads measured in hundreds of kilograms. Another is an unmanned coaxial helicopter, 2 sets of spinning blades stacked on top of each other, which makes it powerful enough to carry heavy loads even at high altitude, where thin air makes most aircraft weak. But the most important detail is the winch system, fitted to another class of cargo drone. Most delivery drones move something from one flat spot to another flat spot. Construction is different. You need to bring a heavy load to a precise point, hold perfectly still while the weight is descending, and lower it slowly and safely, so it does not swing into a worker, a wire, or the side of a cliff. That winch changes everything. The drone stops being a delivery machine. It starts acting like a flying crane. And once you have a fleet of those machines doing that all day long, the mountain stops being a barrier. It becomes just another coordinate in the flight plan. The real proof of what these machines can do is not in the specifications. It is in the actual jobs they have already completed. And 3 cases in particular show exactly why this technology is spreading fast. The first is the Yunnan project from May 2025, that opened this video. The full story is even more striking up close. Construction crews needed to build high-voltage transmission towers in a county where limestone peaks rise sharply through protected rainforest. The area is also part of an elephant migration corridor, and that detail matters enormously. Any ground disturbance could seriously disrupt wildlife movement in a region protected under Chinese environmental regulations. A traditional construction approach would have required either cutting through the forest to build an access road, which was not acceptable, or spending weeks setting up a cableway system before any tower work could even begin. Either way, the land was going to take a hit. The drone fleet changed both of those facts at once. 16 heavy-lift drones flew repeated routes up into the mountains over 3 days, carrying steel tower parts, concrete components, and rigging equipment directly to the build sites with tight positioning. By the end, 180 tons of material had been moved through the air. The forest stayed intact. No cableway was built. No road was cut. The mountain just got built on. The second case happened in Xinjiang, where a maintenance crew needed to service a transmission tower located across a rough river and on an unstable slope. In the old way, workers carried tools and rigging gear by hand over that dangerous ground. One way alone took hours. It was exhausting. It was risky. The terrain itself was the enemy before any actual work even started. A cargo drone with a winch completed the same tool transfer in 2 flights. Total delivery time was under 30 minutes. But the number that matters most is not 30 minutes. It is 0. As in 0 workers had to cross that river and climb that slope. The drone took the most dangerous part of the job away from the humans entirely. The third case came from Hubei during a winter freeze in a remote area. Ice had built up on transmission lines, and that is more serious than it sounds. Extra weight from ice can damage equipment and trigger outages across wide areas. But the bigger problem is how you fix it. Clearing ice from live power lines in freezing temperatures with strong winds puts crews near high-voltage steel in brutal conditions. That combination has hurt and killed workers for decades across the global power industry. China used drones to keep people away from that situation entirely. One drone carried a controlled heat source to melt ice directly on the line. Another drone used a suspended beam to physically knock ice loose. It looked a little unusual on video, but the logic was clean. Put the machine in the danger zone. Keep the human away from it. What connects these 3 cases is not the technology itself. It is what the technology is removing. In Yunnan, it removed the need to destroy protected land. In Xinjiang, it removed the dangerous carry through rough terrain. In Hubei, it removed the deadly climb to frozen live power lines. The drone is not replacing every worker or every piece of equipment. It is going after the worst part of each job and making that part disappear. Now here is the part of this story that most people do not know. The uncomfortable truth is that the United States was not always behind on this kind of technology. America actually had a serious heavy-lift drone capability before China's construction machines became famous. The machine was called the Common K-MAX. It started as a crude helicopter with an unusual intermeshing rotor design. 2 rotors crossed like an X and spinning in opposite directions. That design made it exceptionally good at lifting heavy loads. The military eventually turned it into an unmanned aircraft and deployed it with the Marine Corps in Afghanistan, where it carried supplies to remote outposts in terrain where sending humans was genuinely dangerous. It worked. The test was real. The capability was proven. America had a functioning autonomous heavy-lift machine, operating in exactly the kind of difficult terrain where China's drones would later make headlines. But here is what happened next. The K-MAX never became a civilian tool. It was expensive to maintain, hard to scale, and the program stayed narrowly tied to military use. Production eventually stopped after only a small number of aircraft were ever built. The capability existed, proved itself, and then quietly faded, without ever becoming part of everyday infrastructure work. America built a remarkable machine. China built a market around the mission. That difference turns out to matter enormously. And then regulation made the gap wider. In the United States, flying a large heavy drone over real infrastructure requires navigating approval processes that can take a very long time. Larger platforms do not fit neatly into standard commercial drone rules. Operations where the pilot cannot see the drone with their own eyes need special authorization. Those rules exist for good reasons. Heavy machines flying over people and infrastructure carry real risk, and the approval process is meant to make sure that risk is managed carefully. But every delay in approvals makes it harder for a company to build experience with the technology. Less experience means less investment. Less investment means fewer machines get built. Fewer machines mean the whole market stays small and slow to grow. China approached the same problem from a completely different direction. Drone airspace there has been built out as a layer of infrastructure rather than treated as a regulatory puzzle to solve case by case. According to reporting on China's urban planning developments, Shenzhen already has drone logistics corridors operating as regular routes. Other Chinese cities are planning physical space for drone operations the way older cities planned for roads and parking lots. The signal to manufacturers is simple: build the machines. The system is being designed around them. In the United States, a drone company can have excellent technology and still spend years looking for approvals, insurance arrangements, customers willing to try it, and sites that can accommodate it. The machine is just one part of the challenge. The airspace and the system around it may be the harder part. That is not a small gap. That is a structural difference in how two countries are choosing to grow a new industry. Now step back from the individual drones and the individual projects and look at the bigger picture, because it is easy to get caught up in the specific machines and miss what is actually changing. Construction has always followed the same basic sequence. First you build access, then you build the thing. Access means roads, staging areas, cableways, fuel depots, and all the machinery tracks and cleared ground that have to exist before a single structural piece goes up. That first phase is expensive, slow, and often damaging to the surrounding environment. It is also so normal that most people never even notice it. Heavy lift drones attack that first phase directly. If the material can fly to the build point, a huge chunk of that access preparation disappears. No road needed, no cableway, no weeks of ground prep. The project starts almost immediately at the actual structure, not at a staging area 3 kilometers away. That changes the economics of a lot of projects that currently seem too expensive or too difficult to attempt. A remote mountain tower that would have cost 3 times as much because of access now gets approached differently. A grid line through a protected wetland that was considered nearly impossible now has an option that does not require cutting through the land. An emergency repair in a location that would have taken days to reach can now be handled in hours. This is not science fiction. All of these scenarios have already happened in China in the last 2 years. Real limits still exist, and it is important to be honest about them. Batteries still constrain flight time. Strong wind can turn a precision lift into a genuinely dangerous situation. Thin air at high altitude reduces how much weight a drone can carry. A drone moving 100 kilograms is genuinely not the same thing as a crane lifting a full structural module. But the direction is set. These machines do not need to replace every crane or every road to change how construction works. They only need to remove the access barrier on the projects where that barrier was the biggest cost. Once that becomes reliable and routine, the economics of building in difficult places shift permanently. There is one more dimension to this that sits quietly in the background of every conversation about Chinese drone technology. A machine that can carry construction materials into a remote mountain location with precision can, in theory, carry other kinds of payloads into similar terrain. Western governments are aware of this dual-use potential, and it is why Chinese drone platforms face growing scrutiny and restrictions in the United States and Europe. But that restriction creates its own problem. If the most capable platforms are off-limits and domestic alternatives are still expensive and limited, the industry ends up with a gap that no policy announcement can fill on its own. Building restrictions around foreign technology only works if there is a domestic option ready to step into that space. Right now, that option is still catching up. China has a head start on this cycle, not because the technology itself is magic, but because the system around the technology, The approvals, the corridors, the industrial demand, the repeated real-world use, is being built deliberately and quickly. The viral clip of drones carrying tower pieces up a mountain is not the story. The story is that for a growing number of difficult construction jobs, the road is no longer the first machine on site. The drone is. America still has the engineering talent, the investment capital, and the industrial base to compete in this space. The K-MAX proved that the capability was never out of reach. The question is whether the regulatory system, the market structure, and the industrial pipeline can move fast enough to close the gap before drone-based construction becomes so normal in one part of the world that catching up turns from difficult into nearly impossible. So here is the question worth sitting with. Can America still close this gap? Or has China already turned drones into something too big and too far ahead to catch? Drop your honest answer in the comments. And if this video changed how you see construction, infrastructure, or the technology race happening right now, hit like and subscribe. Because the next shift in this story is already happening, and we will cover it the moment it does.